In this lesson, we'll talk about binary and what it actually means. Now, I'm sure you've heard someone say that computers talk in ones and zeros, but what exactly does that mean and how does that work? Well, it's pretty simple. As humans, we count in base 10, which means we have 10 digits, 0 through 9. Computers can only understand voltage or no voltage. This is at a very low level, right? When different internal computers talk to each other or when you send data across the network, it all boils down to is there voltage or not? So you have 0 and you have 1. 0 is no voltage at all, and 1 is some increase in voltage. So how do computers take these zeros and ones and form them into meaningful data? Well, again, it all boils down to different combinations of them. Um, Computers work in something called base 2, right? So it basically a 2 to a power of a different number. So let's work through 8 bits, right? So at first we have 2 to the power of 0. It equals to 1. Then we have 2 to the power of 2. I'm sorry, to the power of 1. And that equals to 2. Then we have 2 to the power of 2, which equals to 4. Then we have 2 to the power of 3, which equals to 8. Then we have 2 to the power of 4, which equals 16. Then we have 2 to the power of 5, which equals 32. Then we have 2 to the power of 6, which equals 64. 2 to the power of 7, which equals 128. And then finally we have 2 to the power of 8, that equals 256. So these are the different binary combinations um, for an 8-bit kind of character. So let's think about this for a second. A computer is sending over 8 digits, right? 8 binary digits. And the number that it wants it to represent with binary will be a combinations of this set. So for example, if you wanted to send over a 1, all these would be zeros, followed by a 1 in this spot. And that equals to 1 in base 10. If you wanted to send a 4, for example, these all would be zeros. There will be a 1 over here, followed by 2 zeros. Right? It's pretty straightforward. Now, what do we do if you want to send over a 5? We would simply put a 1 over here. So the binary string sent would be 101, and that equals to 5. So through these combinations of putting ones where the desired number is and adding it with other ones, computers can get the numbers that they want.